And so we're talking now the second half of how to actually generate payloads and what a payload actually is. We're going to use a tool in this afternoon called msfvenom, which is kind of like a suite of tools for generating different kinds of payloads and shell codes. I think the easiest way to think about what msfvenom does for us is we are some really, badass hacker ninjas, and, we've done a lot of work doing reconnaissance on our target so that we understand what software it runs and what different versions and all of that. We'll use msfvenom now, once we have that information, to conjure up just the right poison to inject into our target to get what we need, right? And that's how you should think of what msfvenom is for. It's like a crazy ninja poison toolkit that we'll use to generate payloads specific to our target, right? So what do we need to know? We need to know the target's operating system. We need to know our target's architecture. We need to specify what type of payload we want to send, what type of shell we want to receive, and what destination file execution. Where are we going to send this file? What type of connection we want to make? So, reverse shell, bind shell, etc. So what are the target operating systems that we have? Well, we got the big one. We got Windows, we got Linux, but there's more than that, right? The tool that we're going to use, it has very many operating systems that we can play with. For PWK, I'm pretty sure the only machines we have are Windows and Linux. But there's also, you'll see Mac OS X, Unix, Android, iOS, and I think even a few more different operating systems that'll be available to us. So don't fret, you're going to see a lot of options. We're mostly only going to be interested in Windows and Linux because that's what we're learning how to hack right now. So as far as target architecture, what is it that you're looking for on a machine? Is it a 32-bit or a 64-bit machine? So you'll see x86 and x64. Okay, so you can tell what's the target architecture. What type of shells do you want to have this thing produce for you? So do you want a command prompt? Do you want CMD? Do you want bash? Do you want to set up a interpreter shell, which we'll go into a little bit? It's kind of like an advanced shell that Metasploit gives you some extra features for. Okay, and then what do we need? We can make a Windows executable. We can make it as a Linux elf. We can make it as a bash script. We can make it as some kind of other service, right? We can design our payload such that it looks like any of these things. It's specific to our target. We need to get this into our target. Okay. So we have a couple of different types of payloads now. There's two main types, and they're very easy to think of. The confusing part is remembering which one is which when you're looking at them, because their syntax is a little funny. But we have two kinds. We have the unstaged payloads, and this is right. There is no staging. There is only one, or you could think of it as there's only one stage. We're doing it, right? You could imagine this as imagine a small hole inside a wall, and we can fit things inside that small hole. Right? The things we fit inside there, those are our payloads. Sometimes you can fit the whole payload in one chunk, just because of the nature of the hole and the nature of our payload. It just happens to fit right through. However, there may be an occasion where the hole is not very easy to fit things through, and maybe we'll have to chunk up our payload into different chunks and slowly slide it in different pieces, right? So in an unstaged payload, we send the entire payload at one time. One thing, right? Here's the whole payload, put it through the hole, good, it's through, right? Problem is, this is usually a bit easier for attackers. We need a bigger hole to actually fit things in there. It can be caught. Right? So we can catch these unstaged payloads by either using NC or Metasploit. They generate a ton of traffic. Again, we're sending a big thing through at one time. So if anyone's paying attention, they can see. And again, it's fairly easy to detect. For most of PWK, you'll be fine using unstaged payloads for now. If you want to, you can try stage 2. So Why would I use a staged payload? Again, it depends on the vulnerability. It depends on how big that hole actually is, right? If it's a small hole, but maybe I could fit, a few things in at a time, I use a staged payload. Now, a staged payload is a little bit more complicated. It has a little upkeep, right? The way these will generally work is there'll be a small part that kind of goes in first, called like the stager. You can imagine it, again, like a physical wall. A small piece goes in and like opens up a little bit more so we can fit more stuff going inside, right? If you're thinking like that, then that's a staged payload. So they're not complete payloads that you'll put in through all at once. It's like send in half, send in the rest, send in the rest, and then eventually it'll be complete and call back to you if it's a reverse one. The thing is, like I said, they're a little bit more advanced, and you're going to need something to handle all of the staging, right? Because you're not going to manually say, we're going to send this over, we're going to send this over, we're going to send this over. Well, we're going to use a different tool that will handle that for us, right? Now, what's great about them is it's much easier to avoid antivirus. It's much easier to avoid firewalls, right? We're not generating as much traffic. It's a much more sneaky way of getting our payload inside there. And I think that makes sense on the digital side. I think it makes sense in like the real world side. It was like breaking up our package and putting it in, sliding it in, as opposed to having everything in one giant payload. The only main con for us as the users of these is that we need to use Metasploit to catch a staged payload. And use Metasploit to do it. So let's demo, right? I'm going to shell myself or use msfvenom to generate shell code, get that shell code onto my target, which is going to be my Debian machine, and then get myself a shell. So a whole bunch of extra steps to do something you guys have done earlier, but it's important you kind of see as we like kind of unfurl what's going on. So what do I need to know to use msfvenom to build my poison, to build my payload here? I need the target operating system, right? Well, we already know my Debian machine is Linux, right? I think it's x86, but we'll check what the architecture is for the Linux machine. The mechanism of the catch. So are we going to use NC or are we going to use Metasploit to catch it? I'm going to use NC because I'm going to use an unstaged payload at first. Okay, what type of shell do I want? I want a reverse TCP shell. And we'll put the destination of the file execution. So I'm going to want this as like an ELF file. And so let's take a look. I have some options for msfvenom. Personally, I go to a cheat sheet for msfvenom pretty much anytime I want to generate some shell code. So what are the options we're going to have to generally send for a reverse shell? Well, the things you'll normally see: the L port, the L host, right? The machine you want your target to reach back to and send you the shell. You need -P to specify what the payload actually is. You need a -F for what the output format should be, right? If you're trying to attack a Windows machine, you can't use output ELF, right? Windows doesn't know how to read that. We need the right poison for the right machine. Then you have -list. I'll show you how to use that to actually get a list of the options. And Lord, there's a ton. Okay. So let's go here. We're going to generate some shell code. Let me shut off this Apache server first. Stop Apache 2. Cool. And I'll go here. What do we got in here? Clean out the trash. Whatever. I'm not sure. I always get scared when I do that. Scary command. Okay, collapse that. Let's use msfvenom to generate some shell code. msfvenom, right? If I don't know how to do anything, I'll usually just run the command for the first time. And usually we'll get some, look, it errored out because we gave it no options, right? So what is this? It's a Metasploit standalone payload generator, right? Think of it as your box of different venoms specific to your specific targets. It's also a replacement for MSF payload and MSF encode. You may see, depending on how old the resources are on the internet for how to use this, you might see references to MSF payload and MSF encode. Those are the older ways. This msfvenom kind of is a suite of using both. It has both, making payloads and encoding those payloads. Okay, cool. So here we have a usage. What do we have to do? Run msfvenom, give it some options, and you set your variables like this, key value pairs. All right, I can do this. Here's our example. So -p, we said what that was before, but that's for payload. Okay, so it looks like this is the payload. Try and dissect what this means. It's a Windows payload for a interpreter shell. How are we connecting? Reverse TCP connection. Okay. Listening host. Okay, this is where you probably get, or local host. This is where you give your IP to connect back to. -f. Okay, make this an .exe file. -o is for output, I think, and it should make a file called payload.exe. Okay, so that's the rough outline of what this should kind of look like. Let's take a look at what kind of options we have. So you do msfvenom --list. So we have to give it a type. So list off all modules for a particular type. So you do msfvenom -p --list. This might, this is going to give me a lot, probably too much more than I want. But this will list out all of the different payloads that msfvenom knows how to make for us. I should have piped this to -p. Should give me a -p -list payloads. That's what it is. Clear that. Oh, that doesn't work the way I wanted it to. All right, cool. That's what I wanted. A giant wall of text. Should pipe this to less or something. But what I want you to see is just the list of different payloads we have, an absolute smorgasbord of them, right? OSX, right? If you want trying to do something on OSX, right? We have those, we have Linux, right? We have the architecture here. I want you just to kind of look through and get a feel for what we got, right? Different architectures, but you see the same idea. Operating system, architecture, type of connection, sort of thing. And you even get a nice little description for most of them, right? What do they do? Spawn a command shell. This is a staged shell. So if it's staged, that means I need to use Metasploit. If it's unstaged, I don't. So I'm going to look for a staged payload. Then let's do this. I need to actually get the information on my Debian. So I'll do that. So sh root, I'll do it as student at d at 192.206.44. Lab. Okay, so here I am, student at Debian. And usually this is enough information for me to move through, right? So I know we are Linux. I already knew we were Linux. But then I see this i686, and this should help me understand what the architecture is. I should be able to just Google Linux, say x86, 64 or 32. i686 means that you're using 32-bit OS. Cool. So if you didn't know, now you know. So what else do I need to do? I need to generate a payload. So msfvenom -p for payload. And I should be able to payload should be Linux X. What did I say? Means we're 32-bit. So what do we want? Not the 64. You pipe this, you do like this actually. Dash list, payloads, pipe that to less. And because I don't usually look at it this way because it's way too much, I usually just go to msfvenom cheat sheet. I like this one from Red Team Tutorials. I like this one from Frisbee, and I like this one too. All of them are useful to me sometimes. But I like these because they are stripped down, right? It's mostly the ones I'm interested in, which is Linux and Windows and bind and reverse and interpreter or not. So let's take a look. I think I could do /Linux. So here we have all the Linux ones. We have the different architectures. Let's scroll down. We want a x86. Then you see here, there's different kinds of payloads too. Not every payload is send me a shell. Yeah, that's most of the time. But like here, what do you look at this payload? Why is that maybe useful?
It's the highest ranking user ID.
Mm-hmm. You get user ID 0, you are root on a box. So maybe your payload will be, hey, let's use this payload, create a new user. And if there's SSH on that box, maybe I could just SSH on as that user and now I'm root. Cool. All right. So what do we want? I don't want to use interpreter. I don't usually look at it this way. Let me find one of these. MSF payload. Let's do a Linux bind shell. Fine. Do a Linux bind shell first. You guys can do the reverse shell. I thought there was a bind shell here too. Here we go. Reverse. Linux interpreter, Linux reverse shell, x64, single stage. So what is this command running? msfvenom -p for payload. We're running for Linux. 64 shell underscore reverse underscore TCP is the payload. Here's the port, the IP address and port number that you'll set, the file type you want to send it to, and then this is just redirecting it to shell.elf. So let's try that. -p Linux x 64 x86. Right, because that's what our target is. Target is i686. And i686 is 32. Cool. We want this one. Shell underscore reverse underscore TCP. And here's the mnemonic to remember the difference between staged and unstaged. Underscore, unstaged. So you see how there's an underscore in between shell and reverse TCP. If you look at the staged, it has like shell / reverse underscore TCP. I'll show you. That's a mnemonic. I don't know why they do it that way. Quite frankly, I think it's a little bit confusing, but it should be that way sometimes, you know. All right. So there's that payload. I think you could do -L to list the options. No, there's a way to list the options. --list -options. It should show me things that I already expect. Should be like a port that I have to put in, an IP address that I have to put in. Let's take a look. Okay, so here we go. Options for this payload. get some nice information, right? It's Linux command shell, reverse TCP, right? What is it for? This is the name for Linux for x86, right? x86 is my target. Or, oh, is it? Here's the command that we're going to send. Send me bin shell. Here's the port. It already has one by default as 4444. And there's the L host. So that needs to be set. You can see it's currently not set, right? There's no IP address. How is it going to send me a reverse shell? You can see there's advanced options as well. You don't need to mess around with these, but you can look at them. I'm trying to think if I ever really have had to, and not outside of specific situations, I don't think. So these are the important ones. So we need to add L host and L port if we want to change it. So I'm just going to run up there, clear this so you can see. So what were those things we needed to add? Shell underscore R host and L port. So R host equals, that should be my IP address, which is 192.168. What am I? 206? I'll never remember. 119.206. Okay. That didn't work. Okay, what else did we need to set here? I'm just following this one. Our host is the IP address, L port is the port. We'll do 9,000. That looks fine. And I think that's all we got to place. Oh, what type of file? -f elf. And we'll call it bad stuff.elf. No, just bad stuff. And then you let it do stuff. Okay, cool. There it is. Got the bad stuff. Should be some shell code. I'll cat it. I don't think it'll break my terminal, but there you go. Right. It's got the elf string, and then it's some actual computer code that we cannot understand. Didn't break my terminal, thankfully. So now we got to get that onto.
Run the file command on that real quick. I just want to see what
it's
it
going
looks
to say
like.
elf because that's why. Elf.
Okay.
Yeah, no problem. Good question. All right, so I guess it just sets those magic bytes as elf. Okay, should be good. Now we have the problem of get this payload onto my target. We'll talk about the different ways we can actually do that tomorrow. There's a whole bunch of different techniques that you might have to try, right? It just depends on the hole that you have, right? That's what's going to determine how you do this. So since I already own this box and you're already familiar with stuff, I'm just going to use secure copy. This way I could copy this from here to my Debian machine. So I'll put it at student at, what's my Debian client IP address? These are all the same. Right, so copy it at that IP address, colon. I could put it under root, I guess. Bad stuff. This looks good. Is it 172? Did I type this wrong? It's 192. Derp. That will never work. 192.168. Man, way off. Looking at the wrong number. 206.44. Okay, looks like you're good. Oh, yeah. Lab. Oh, is it because student doesn't have access to do that? Student can't put things in root. That makes sense. Root can put things in root. Cool, that worked. Here I am on that other box. I'm gonna sudo. Okay, now I'm root here. I can go to there's that bad stuff. Okay, this was a reverse shell. So if everything worked well, and I remembered where what port I said, I believe it was 9,000. It was. So let's just nc-nlvp 9,000. And now, hopefully, if we run bad stuff, I think I did something wrong. Maybe we didn't get a connection. So I gotta check this again. What did I do wrong? Oops, probably get this going again. 9,000.
Is it because you changed the the R host, not the L host?
Did I put the wrong thing in there? It could totally be. They should be the same. Let's generate the payload again. msfvenom. There. Go away, bad stuff. You're not useful. msfvenom. I'm gonna even have this open right next to me. My cheat sheet. Go away. I like my team.
When you looked at the web page, it said R host, but when you were in the actual file, it said L host was blank.
Oh, that would definitely be wrong then. Let's go up here and just rerun it. It needed L host and L port, right? Should be for local. Let's try this. We'll do the same things again. Okay, looks good. SCP. Did I delete this? Okay. Do that again. Got it over. Get a listener going. What's going on here? Bad habits. We're listening. Have the payload here. Got a connection, so yay. All right, let's confirm host name, Stebian, IP matter. And here we go. We have our somewhat crappy shell. Can we get, oh yeah, you don't get any pressing up to go back. And sometimes, yeah, this one we get to delete, but sometimes you get crappy shells that you can't do any of that. You can't press up. You don't get any command, you don't get any tab complete and stuff like that. Cool. So that works. Thank you for that catch on me not typing correctly. totally like you will do this. You will make the same mistake too. So I'm glad that I get to make it in front of you so you can debug with me. We can try now and show you a staged payload, but I think I'd rather let you guys try and do some unstaged payloads first. So use msfvenom to generate a reverse shell for your Debian machine, just like I did here, and for your Windows machine. Slightly different options, but same idea. Then you can get them over. I'll give you a hint for how to get your Windows. I think it has one in the, for how to get the file over to the Windows machine. Questions, comments? How do we feel about msfvenom? I remember the first time I learned about it. I'll tell you about that.